8.1d, we're going to actually construct a confidence interval and then again understand the difference it is from a confidence level. Now here's a real life example I want to show you. This was a Fox News poll back when Obama was in office, and the headlines was, Obama ends year with a majority disapproving. Where does that data come from? Let me show you. What was reported is right here. At the end of his fifth year in office, 41% of voters approved the job Obama is doing as president, while 53% disapprove. What you're seeing here reported are actually the point estimates and not actual confidence intervals. Well, where are they getting this data? You want to question this type of stuff. Now, when news organizations actually state some statistics, or in that case a point estimate or a confidence interval, you should be able to find where they got their information and how they did their methodology. This is just interesting to see how things are actually spoken about in terms of what we've been learning in class. They talked about their methodology here. They said here the poll was conducted by telephone with live interviewers from a certain date among a random national sample of 1,027 registered voters. The landline and cell phone numbers were randomly selected for inclusion in the survey using a probability proportionate to size method, which means the phone numbers for each state are proportional to the number of voters in each state. So they're clearly talking to us about here our Chapter 4 content. So it is important, again, how do we feel about this data? Just because we hear information is reported, you want to understand how it was taken. Do we see any bias in this? I think in how the survey was structured, we're okay that we do not have really any undercoverage or convenient sample or voluntary sample. But we might see some bias after the survey in terms of maybe the response bias. When they tried calling people, were they there to answer? And then we also would want to question, are they telling the truth? Now, we've already talked about confidence interval versus confidence level, and I want to kind of test your knowledge on that. What I did here is I went to an applet and I ran various confidence intervals. So for this particular curve, you're going to see this was the confidence interval, or how long the answers were. The dot there shows the mean of the interval. And this is many, many different intervals that had been conducted. The green line here going down the middle is the actual mean of our true population. We see the same thing here. The mean is down the middle. And these are a variety of confidence intervals that were computed. Notice the red ones are highlighted because they are not capturing the true population mean. Same thing for this one. So my first question for you is this. Is this information down here actually showing us the definition of a confidence level or a confidence interval? Well, what it is, this is actually a confidence level. Remember, a confidence level says if you were to construct a confidence interval over and over again, it's the percent of confidence intervals that would actually include the true population parameter, which we see in here designated again by the green line. So here's the next question. Of these three pictures of the confidence level, which one do you think would be representative best of a 90% confidence level? Well, if you assume that we have about 100 different intervals graphed here, even though it's not exactly that, you're going to notice on this middle one, for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, not including the true population mean. This one right here would be defined as the 90% confidence level. Now, how about the other two? Which one is 95 and which one is 99? This one to the right is actually missing about 5 of the intervals, so this here is a 95% confidence level. And lastly, this one over here captures most of them. Actually, we don't see any of them missing, but this is a 99% confidence level. So if we put the vocab to it again, what confidence level is, the best way to describe it is, in this case, we have actually 25 samples that we see to the left. So in 25 samples of size n from the same population, X% of all samples given an interval that capture the true population mean mu. So if you take a look at this one, this is 25 confidence intervals. In this case, of the 25, one of them does not capture the true population mean. Fine, let's take these results and times it by 4. If we times this by 4, then this would come up to be about a 96% confidence level. Because out of 100, it would look like 4 of them would be missed. Now, keep in mind, what is confidence interval? Confidence interval is that we would say, for example, for this bottom interval, that we are 96% confident that the true population parameter resides within this interval. So here, if they want you to interpret a confidence interval, if you chose 95% as our confidence level, we will build an interval that stretches 2 standard deviations from our p hat, or our sample proportion, in either direction. If this is the case, here's what we would say. We would say the confidence interval is that we are C% confident, or in this case, 95% confident, that the interval from our low end to our high end, compute what it is, captures the true value of our population parameter. Let's clarify that again with confidence level. The best way to define confidence level when you're asked is to say this. Confidence level is that we are C%, or in this case 95%, of all the samples of a given size from this population will result in an interval that captures the unknown population parameter. I highly recommend that you just ingrain these 2 definitions in your brain because you are guaranteed to see these within your AP exam. Let's do a real life example. Here we have the presidential approval rating. So according to the Gallup poll in 2010, 95% confidence interval for the true proportion of Americans who was approved of the Barack Obama's job as president was 44% plus or minus a 3% margin of error. Let's interpret the confidence interval and the confidence level. In this case, the confidence interval, we would say, we are 95% confident that the interval from 41 to 47, then subtract the margin of error and add the margin of error, captures the true proportion of Americans who approve of the job Barack Obama was doing as president at the time of the poll. This confidence interval is actually stated in context, which is what you'll want to do. On the flip side, for the confidence level, we would actually say that in 95% of all possible samples of the same size, the resulting confidence interval would capture the true proportion of Americans who approve of the job Barack Obama was doing as president. Now, when you calculate a confidence interval, this right here is going to be your standard format for it. And you will find this formula on the actual AP exam formula sheet. What this says is you're going to take your statistic or your point estimate, you're going to add or subtract to it the critical value times the standard deviation of the statistic. So this really is the standard deviation like we did back in Chapter 1. This critical value, we're going to have to use our ability from Chapter 2 with normal curves to compute the critical value. Now what the critical value is it depends on the level of confidence desired. Do we want to be 95% confident or 99? It changes with the level we choose. The critical value will also be computed based on using the sampling distribution of the statistic that we are analyzing. So let's go ahead and look at how to do this. Now, we didn't do that mystery mean example, but we're going to talk about it a little bit. If in the mystery number that the teacher was thinking of and had written down on her paper on her desk, if we thought the true mean was the number 186, then we can use this information and this given information here too. So the mean of the population we think is 186. I will tell you here that the 20 here is the standard deviation of the population, and the 16 here is going to stand for the sample size that was taken. So what we would need to do, this is for a sampling distribution, we would actually need to come on in and compute the critical value. In this case, the critical value is going to be the number 1.96. And let me show you where that comes from. If we want to be 95% confident, I'm going to actually sketch here a normal curve. So in the normal curve, we have this. To be 95% confident means I want 95% of the curve. But if the mean is in the middle, to have 95% of the curve, I want to be equally balanced over here and on this side. So technically, what the 95% confidence interval is this range. So the number that I see in here represents 95%. So what the critical value says is, hey, tell me at what z-value is that? There is actually a z-value associated with that. Remember, when we standardize, the z-value for the center or the mean is 0. So what is this z-value going to be? Well, I can do that. Back in Chapter 2, we found critical values or z-values using inverse norm. Now notice though, the area under the curve I put in inverse norm is not 95%. Why isn't it 95%? Is because it reads it from here all the way to the tail. If this red region is 95%, it means that there's another 5% that I didn't use. That 5% would have to be in each tail, which means there's another 2.5% in this lower tail. So the area under the curve is really 97.5%. Fine, at 97.5%, it's standardized with a mean of 0, standard deviation of 1. If you enter that into the calculator, it will come back with a value of 1.96. Okay, so I need the critical value. Now I need my mean or my point estimate. Remember, if we're doing means, we know the mu of x bar is going to be the same as the mean of the population. How do I find the standard deviation of x bar? The formula is take the standard deviation over the square root of the sample size. And when you do that, you're going to end up getting that this would be the number 5. So to construct the confidence interval, what I'm going to do is I'm going to take the point estimate, do plus or minus the critical value times the standard deviation. And what I would end up writing is this right here. Our 1.86 is our mu of x plus or minus the critical value I computed times the standard deviation. I could actually compute this and get the interval. Okay, great. Now, what happens if we change it from 95% to 99%? Well, really, the mean and the standard deviation is going to stay exactly the same. So we're going to use 186 and we use 5. But this critical value will differ. What we have to do is just imagine our normal curve. This is our mean if it's standardized at 0. To be 99% means we want 99% of the curve equally balanced to the right and the left. But don't forget, there's some tails here. This is equally balanced. There's 1 more percent equally divided amongst each tail, so the percent that's here is actually going to be 0.5. So what do I actually want to type in for inverse norm on this one? I would just adjust it and I would say give me the inverse norm. The area under the curve this time is 0.995 with a mean of 0, standard deviation of 1. When you do that, you get 2.58. So what I'm going to do, my new interval is going to look like this. 186 plus or minus 2.58 times 5, which is our standard deviation. And we could compute the interval from a low end and a high end on that one. Let's wrap it up. What happens if we do 90% confidence? Folks, for 90%, it's going to work the same way. Let's just visualize it though. For 90%, we want 90% of the curve. That means there's 10% left over. To equally divide 10% amongst 2 tails means there's 0.05 here. So on that, when you add these together, you actually are going to do an inverse norm of 0.95, 0, and 1. That will give you the new critical value that you would actually replace this with, which ends up being approximately 1.65. So the new interval would be adjusted. We'd use 186 as our point estimate, plus or minus our critical value of 1.65 times our standard deviation. Wrap up with check your understanding. How much does fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. So here, interpret the confidence interval. The confidence interval for this would be, we are 95% confident that the interval from 2.84 to 7.55 grams captures the true deviation of fat content of brand X hot dogs. How does the confidence level differ? Well, the definition for confidence level: in 95% of all possible samples of 10 brand X hot dogs, the resulting confidence interval would capture the true standard deviation. Last question here, true or false? The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Okay, here's where you have to be careful. What word are they using is chance. Remember, I told you the word probability is absolutely wrong. Chance is another word for probability. So this is actually incorrectly stated. But the one thing you really want to think about is probability. What is the probability about this interval? Well, here's what we would say. This is false because the probability is either 1 if the interval contains the true standard deviation, or it's 0 if it doesn't. This either has it or it doesn't have it. So when we talk probability, think of it that way. If this has the true mean, the probability of it happening is 1. If it doesn't, it's 0. So careful with the word usage of probability or chance.